Hello, my name is Emilin Mathew, and my research focused on identifying a biomarker or a detector for schizophrenia in the prefrontal cortex, and then creating a device to electrically stimulate the brain. To give some context, schizophrenia is a prevalent disorder affecting behavioral and cognitive abilities of individuals. In my first phase, I worked with an ion channel known as HCN1, which is hypothesized to affect memory storage and retrieval information, which are both affected in schizophrenia. I hypothesized, therefore, that HCN1 would increase in the schizophrenic model. And in order to test this, I analyzed the changing activity of these channels in a schizophrenic and control prefrontal cortex mouse model using immunofluorescence. In my experiment, the infralimbic region of the prefrontal cortex saw an increase of about 133%, which was proven to be statistically significant. This supported my first hypothesis and can be a potential target in the future for therapies. The second phase focused on finding a potential solution to these errors. Neurological disorders are increasingly being treated by deep brain stimulation. So, the second phase of my experiment had the goal of creating an electrical stimulating device to bring that solution to schizophrenic patients. I created a self powered system using silk because of its natural piezoelectric potential. I altered silk by adding piezoelectric composites to enhance its natural piezoelectricity. I used an ultrasound device to then deliver kinetic energy and used a multimeter to quantify the voltage being produced. My most effective model was 2 moles of zinc oxide combined with silk to make my hydrogel, which produced zero point 0.3 millivolts of biologically relevant electricity. Overall, this experiment provides an understanding of how schizophrenia affects electrical activity by disbalancing the HCN1 ion channel and how we can potentially use a self powered device to target electrical therapy at regions affected by schizophrenia. Thank you.